Hello everyone. In today's session we are here to discuss about Pulley constraint. We use Pulley constraint to derive relationship between the motion of two or more blocks which are tied together through piece of string or pulleys. So in today's session we'll see a generic approach we take in order to derive the relationship between the motion of two or more blocks. So we will see a very simple example today. Probably you may not use Pulley constraint, you can directly derive it without Pulley constraint the situation, but for a more complex situation sometimes the derivation is not that easy and you have to follow this approach which we are going to discuss in order to derive the relationship between the motions. Okay, let's consider this problem where we have two block situation. We have two masses m1 and m2 which are tied together through a piece of string, and we have pulleys here also. So before beginning the problem, we'll assume that the pulleys are smooth and light, and the thread is also light, so that the tension is constant throughout the string. Okay, so how do we approach this problem? How will we derive the relationship between mass m1 and m2? So the very first step would be to assume the motion of these two blocks. Suppose mass m1 is heavier and it moves by a distance x downwards, and since m1 is moving downward, m2 will obviously moves upward. So I'll assume that it moves by a distance y. The basic funda about this concept is that the string length remains constant. Whatever be the situation, the string length will remain the same. So here in this problem we can see there are three sections of string. This is section 1, this is section 2, and this is section number 3. Suppose if I say that section 1 has length n1, section 2 has length l2, section 3 has length l3, then l1 plus l2 plus l3 will always remain constant. So this is the basic funda behind the concept. So let's go back to our assumption that mass m1 will move downwards by distance x and mass m2 will move upwards by distance y. For deriving the relationship between x and y, motion of these two blocks, I'll see the change in length of the string segment wise. So in this case we have three segments, L1, L2 and L3. So when the mass m1 will go downward by distance x, what will happen to section L1? Section L1 will increase by length x. Similarly, when mass m2 will move by distance y upwards, this pulley will also move by distance y upward, and since the string is tight, L2 will be shortened by distance y. Due to this motion, the string length is reducing. I'll the sign as of the change as minus y. So this plus x was the increase in length of L1, minus y is decrease in length of L2, and similarly L3 will also decrease by y. And now what is this? These are all the change in length. Now we know that since the string is tight and it is inextensible, the change in length will be equal to 0. This should be equal to 0. On solving this, we see that x is equal to 2y. This means that the relationship between the motion of these two blocks is given by this equation number 1. Okay, so if someone asks you what if mass m1 is moving by velocity v, what will be the velocity of mass m2, you can simply put the velocity here in this equation and you can give him the answer. If I say that it is moving by acceleration a1 and it is moving by acceleration a2, I'll differentiate this equation by 2 times distances. I'll differentiate these time and we can get the relationship between the acceleration as a1 is equal to 2 a2. So this is how we derive the relationship between the acceleration or velocity or distance moved between two or more blocks using Pulley constraint. I hope this was an informative concept that you have gained today.